An anchor is one of the most important safety devices on any vessel. A ship doesn't only need to stop when it reaches a dock. It may need to wait outside a port before entering, find shelter when the weather gets worse, or, if the engine, rudder, or another system fails, temporarily hold itself in place so it doesn't get pushed into danger by the wind and current. But do these massive vessels really hold their position with nothing more than a small-looking piece of metal hanging from the bow? The reality is not quite like that. What actually keeps a ship in place is often not the anchor itself. Or more accurately, the anchor does not do the job alone. If you dropped an anchor straight into the middle of an ocean that is several thousand meters deep, it would do almost nothing. It would not suddenly stop the ship, and it would not grab the seafloor like it does in the movies. And if the chain is released the wrong way, pulled at the wrong angle, or recovered incorrectly, a huge amount of steel chain can end up hanging almost vertically in the water, sending dangerous loads into the windlass, the chain, and even the bow structure of the ship. So if that iron anchor is not holding the ship by itself, why can a huge cargo ship sit so calmly on the surface of the sea? How does the crew know where to drop anchor? How do they decide how much chain to let out? And once a 15 to 20 ton anchor has dug itself into the seabed, how does the ship ever pull it back up? In this video, we are going to look at how ship anchors really work, and at a few things you may never have thought about before. When a ship is preparing to anchor, the captain does not simply choose a random spot and drop the anchor over the side. The crew first has to confirm whether the area is approved for anchoring, how deep the water is, whether the seabed is sand, mud, or rock, whether there are other ships nearby, and whether wind and current are likely to push the vessel. This is not just routine. Water depth determines how much chain needs to be released. The seabed determines whether the anchor can get a good hold. Sand and mud make it easier for the flukes to dig in, while a rocky bottom can cause the anchor to get stuck or fail to hold properly. The position of nearby ships also matters, because once a ship is anchored, it is not nailed to one exact point. It will slowly swing around the anchor point as the wind and current push against it. So an anchor does not start working just because it touches the bottom. It needs the right kind of seabed, and it needs enough chain to work with it. Many people assume a ship stops because the anchor itself is heavy. And large ship anchors are heavy. The anchor on a large cruise ship or commercial vessel can weigh around 15 to 20 tons. But in a real anchoring system, the more important part is often not the anchor. It is the huge steel chain attached behind it. This is not ordinary chain. A single link in the anchor chain of a large vessel can weigh more than 130 kilograms. The full chain can be more than 300 meters long, and the total chain weight can reach 60 to 120 tons. So when a ship drops anchor, it is not just lowering a 15 to 20 ton piece of metal. It is also laying a much heavier length of steel chain across the seabed. That is the real key to holding the ship in place. After the anchor reaches the seabed, the chain does not pull on the ship like a straight rope. A long section of it lies on the bottom, while another section curves upward through the water. That curved shape is known in engineering as a catenary. When waves or current push the ship backward, the ship does not immediately pull on the anchor. First, it has to pull on that long section of chain lying on the seabed. Imagine 60 to 120 tons of steel chain resting on the bottom. Before the ship can really move, it has to start lifting and dragging that chain, link by link. That process uses up energy by itself. That is why the anchor chain acts like a giant shock absorber. When waves push the ship, the chain absorbs part of the force first. By the time the pull reaches the anchor, the force is already close to horizontal. That angle is extremely important because what an anchor fears most is not being dragged sideways. It is being pulled upward. When the pull stays horizontal, the anchor does not immediately pop out. Instead, its own shape helps it dig deeper into the sand or mud. That is the action that actually holds the ship. The flukes dig into the seabed. The chain presses down along the bottom. The ship's pull reaches the anchor at a low, nearly horizontal angle. The more the ship tries to drift backward, the more the anchor tends to bury itself deeper into the seabed. It does not work like a hook grabbing a rock. It works more like a plow cutting into the ground. That is how an anchor that looks relatively small can hold a massive ship. When anchoring, the crew also has to answer one very important question: how much chain should they let out? This is not guesswork. In navigation, there is a common concept called scope, which is the ratio between the length of anchor chain released and the depth of the water. Under normal conditions, the amount of chain released is usually about 5 to 7 times the water depth. So if the water is 30 meters deep, the ship may release 150 to 210 meters of chain. If the wind is strong, the waves are high, or the current is powerful, that ratio may need to be increased even further. The reason is simple. The shorter the chain, the more likely the pull is to become upward. Once the anchor is pulled upward, it can break free from the seabed. The longer the chain, the more of it can lie along the bottom. The closer the pulling angle stays to horizontal, and the more likely the anchor is to keep biting into the seabed. This is also why ships cannot drop anchor just anywhere. If a ship breaks down in the middle of the Pacific Ocean, can it simply throw the anchor down and stop itself? In most cases, no. Ordinary commercial ships can generally use traditional anchoring only in relatively shallow water, commonly within a range of about 100 to 200 meters. But in the open ocean, the water depth can exceed 3,000 meters. If the ship still followed the 5 to 7 times depth rule, it would need 15,000 to 21,000 meters of steel chain. That is almost impossible. The problem is not just whether the ship has enough space for that much chain. The chain's own weight would become dangerous. A huge length of steel hanging vertically in the water would place enormous loads on the windlass, the bow structure, and the chain itself. Before the anchor ever started holding the ship, the equipment might already be overloaded. That is why ordinary ships do not use traditional anchoring in deep ocean water. They may drift while waiting for help or better conditions. Specialized engineering vessels, drill ships, and research vessels may use a dynamic positioning system instead. These ships do not hold themselves in place by connecting to the seabed. Instead, computers control multiple thrusters, constantly correcting the ship's position so it can stay as close as possible to the same point. In that case, the ship is not being held by the seabed. It is constantly fighting the wind, waves, and current. Back to normal anchoring. When a ship reaches a suitable shallow anchorage, the crew still needs to know how much chain has already been released. You cannot lower 300 meters of steel chain into the sea and then measure it with a tape measure. So anchor chains are divided into standard lengths. In English, each length is commonly called a shot or a shackle. One standard length of anchor chain is 27.5 meters or 90 feet. These sections are connected by special joining links, and the area around those links is painted in obvious colors, such as white, red, or blue, so the crew can identify them. As the chain slides out through the hosepipe at the bow, a crew member watches the colored markings and counts how many lengths of chain have gone out. Then they report that number to the bridge by radio. 3 shots in the water means about 82.5 meters of chain has been released. The bridge uses that information to judge how much weight is lying on the seabed, whether the chain angle is good enough, and whether the ship has entered a stable anchoring condition. When the anchor first reaches the seabed, it has not really started working yet. It may simply be lying on the bottom, and it may not even be in the right position. At that point, the ship slowly moves backward, allowing the chain to pull the anchor horizontally. As the anchor is dragged, its shape causes the flukes to rotate downward and begin digging into the seabed. If the bottom is soft mud or sand, the anchor digs deeper as it is pulled. In some cases, it can disappear completely into the sediment. The more the wind and waves push the ship backward, the greater the horizontal load on the anchor becomes, and the more firmly it can hold. This is the most counterintuitive part of how anchors work. An anchor does not hold a ship by simply standing still. It holds because it is pulled in the correct direction and then actively digs itself into the seabed. When the ship needs to leave, The whole process has to be reversed. The crew starts the windlass at the bow and slowly hauls the heavy chain back in. As the chain becomes shorter, the steel that was lying on the seabed begins to lift off the bottom. The ship also slowly moves toward the position of the anchor, making the chain more and more vertical. Once that angle changes, the anchor's behavior changes too. The horizontal pull that once made it dig deeper is replaced by an upward pull that breaks it free from the mud. Once the anchor is released from the seabed, the windlass continues lifting it out of the water. When the anchor comes up, it is often covered in tons of thick, foul-smelling mud. Before it enters the ship, high-pressure water jets inside the hosepipe wash the mud away to keep the chain locker clean. Once the anchor is secured against the side of the hull, the ship is free to move again until the next time the anchor is needed. A ship anchor has never been just a simple metal hook. Its real job is to work together with the chain, the seabed, the ship's movement, and the angle of pull, forming a temporary braking system at sea. Thanks for watching. If you enjoyed this episode, please hit the like button and subscribe. And if you have any thoughts, feel free to leave them in the comments. See you in the next video.